Good day, Sir Glenn. I am Sari Brianna Esbuhat from Group 7 of BSEE-1201. I am now going to present you our code, the Ohm's Law Calculator. An Ohm's Law Calculator is a tool that helps us compute voltage, current, resistance, or power using formulas based on Ohm's Law. Instead of solving equations manually, this program allows users to input known values and it automatically calculates the missing one. This program is built using defined functions. Each one performs a specific task such as showing information, converting units, or solving equations. This structure keeps our code organized, readable, and reusable. Defined functions also allow us to call specific tasks anytime without repeating code, which makes the program much more efficient. For the first part of our program, we created a function called showDefinition. This function uses the print command to display the meaning of Ohm's law, which states that the current through a conductor between 2 points is already proportional to the voltage across the 2 points. Next is the relationship function or the showRelationship function. It uses the print command to show how voltage, current, and resistance are mathematically connected. It helps users understand how changing one variable will affect the others using formulas derived from Ohm's law. Next is the showVariables function. It introduces the 4 major elements of Ohm's law: the voltage, current, resistance, and power. It also shows their respective units: volts for voltage, amps for current, ohms for resistance, and watts for powers. And this explains what role each one plays in electrical circuits. Next, the showFormulas function. It presents the most common formulas used in Ohm's law. This includes voltage is equals to current times resistance, current is equals to voltage divided by resistance, resistance is equals to voltage divided by current, and power is equals to voltage times current. Next one is the converts units. In converts units function, we added interactivity using the input functions. The user is given several conversion options such as milliamps to amps, amps to milliamps, kiloamps to ohms, and ohms to kiloohms. After the user makes the selection, the program uses if or elif statements to determine which formula to apply. The input is then processed using basic math and the result is displayed using the print command. Next is the calculate Ohm's law function. Allows user to solve for one unknown variable by typing x for the variable. For example, if the user knows the voltage and resistance but not the current, they can put x for the current. The function then uses conditional statements to check which variable is missing and apply the correct formula accordingly. Next is the calculate power function. The user is asked to put input voltage and current values. The function calculates power using the formula of power is equals to voltage times current. If the user inputs incorrect values like letters instead of numbers, the program detects the error and gives a warning message. Lastly, the main menu function is the control center of the program. It presents a list of numbered options to the users, like viewing definitions, converting units, or performing calculations. Using a loop structure, the menu keeps running and letting the user choose until they select the option to exit the program. So now I am going to run this program to see how Ohm's law calculators works. So now I am going to show you how Ohm's law calculator works. As you can see, we have a greeting message here. Greetings engineers, let's master the Ohm's law. So as you can see, we have the 8 options that we can choose from. And now let's pick one. For example, I choose to calculate the voltage, resistance, or the current. For example, I have a value for voltage,
a value for current, but I don't have a value for resistance.
So let's compute it. So as you can see, the program compute the value for resistance. And now let's have another one. Let's now compute the power. It's the number 6 option. And need to now enter the voltage. For example, 10. Current 11. And now we have a value for power. And now, let's try another one. Let's convert a unit. For example, I chose amps to milliamps. I want to convert an ampere to milliampere. As I input a value 120. So, 120 amperes equals to 120,000 milliamperes. So, as you can see, as you notice, the program is on loop and it will not exit until the user exit the program. So, if I exit the program, the program has ended. So, that's it for today. Thank you for listening. Once again, I am Sari Brianna S. Buhat. Thank you.